All right, geometry guys, this is one more proof I want to look at. And it's basically kind of using that same idea. We're trying to prove this triangle is congruent to this triangle. That's this top triangle congruent to this bottom triangle. And we're going to use the idea of a midpoint in there to help us out. So how do we start every two-column proof? You start with your statements and your conclusion. And here's how that goes. You start with your given statement. AC is congruent to EC. That's given. And then mark that on the actual picture if it gives it to you. 2, C is the midpoint of BD. That's also given. Now, think about what does it mean to be a midpoint. A midpoint actually means cuts in half. So C is exactly halfway between B and D. So what I can say is BC is congruent to DC. And I know that because C is the midpoint. So the way I say that is this. BC is congruent to DC by definition of midpoint. All right, because C is a midpoint, by definition of midpoint, midpoint means cuts exactly in half, I can say that those two segments are congruent to each other. Now, I don't know anything about AB and DE, so I can't show that those two are congruent even though it might look like they are. I don't know anything about angles D and E. I don't know anything about A and B. What I could possibly look at is these two angles right here. Those two angles are both made by the same line. Those look like vertical angles to me. So vertical angles are congruent. So what I'm going to say is angle BAC is congruent to angle DAE. Remember, 3 points name an angle. And the reason for that is because vertical angles are congruent. Vertical angles theorem. So vertical angles are going to be congruent. So now, do I have a situation that I can say, yeah, the two triangles are congruent? I do by side, angle, side. Notice it's the angle included in between. It's the angle in between. It's the angle in between. There we go. Nice and easy.